Hello everyone, Andrei here, and today we'll talk with Nikita. He's machine learning engineer from Brutal Lab. Today we'd like to discuss avatar animation technology, which allows you to reproduce human emotions on a virtual 3D model. Well, does avatar animation technology have a unique name?
There is a full name for this project that describes its essence to a large extent, namely avatar animation by capturing facial performance from real-time video.
That's really good. How's the person's face scanned? What are the main points that will be scanned?
The whole process of face scanning can be divided into two stages: detection of a person's face in the image and detection of key points on the found face. The first stage uses a trained classifier which is applied to different parts of the input image. It checks whether there is a human face in them and if there is, with what probability. When the image is completely scanned, we select the fragment of the largest size, which contains a face with the highest probability. Then, the second stage uses another model that is trained to find the key points of a face in the image. This model is applied to the fragment from the previous stage and gives us the coordinates of 68 points, describing the position of facial oval, eyebrows and eyes, nose and mouth. This data helps to determine emotions and facial expressions.
Well, that sounds really good. What is the basic algorithm of technology?
The basic algorithm of this technology consists of 5 steps: face detection, detection of key points on the face, determining appropriate parameters for the 3D model, its construction and visualization. The first 2 steps we have already considered. The third stage of parameterization is that before running the whole job, we get the key 68 points that characterize the person's neutral face. Then, when the person makes different facial expressions to the camera, we record the differences from the neutral face and apply them to the neutral expression of our avatar. In this way, we get the key 68 points already for the avatar. They characterize the same emotions as the human. Next, we use a neural network model, which is trained on a dataset with 60,000 different facial expressions. This model takes 68 points as the input. Once it works, it gives us the output parameters, which define our model in 3-dimensional space.
Yeah, I think that's really interesting. Well, does the program need more points to be scanned to increase accuracy, or does it make sense to use more 68 points, such as additional points on the forehead?
Yes, there are detectors for more points, like for 194, and in general, increasing the number of points can provide more accurate animation. But it's worth considering a few facts about our project. Firstly, we are using a standard camera with no image depth estimation, so we get 2-dimensional data. Secondly, we have a relatively uncomplicated avatar model. In particular, it consists of 5,023 vertices in the space. It means that this model has a limited range of possible emotions. Finally, we work in real time on a processor without using GPU. Under these conditions, increasing the number of points wouldn't provide a significant increase in animation accuracy and would slightly decrease the speed of the whole work. So we believe that the number 68 is quite optimal here.
Cool. How long does it currently take to scan a person's natural facial expression?
On average, it takes approximately 90 milliseconds.
Can the program scan a person's appearance and recreate it on a 3D model, making it as similar as possible to the person and their facial expressions?
Actually, our project works with the fact that the avatar is initially fixed. So this particular program cannot do that. However, it's possible to implement it. The 3D head model that we use can change not only emotions, but also the shape. This ability is not used in our project, but it can be used to create faces similar in shape to users' faces. In addition, it's also possible to create similar textures.
Well, my next question: how does the software currently reproduce human facial expressions on a 3D model?
Yes, inaccuracy in the animation is obviously present. You can see it in some of the facial positions. And there are several reasons for that. First of all, we use a regular camera and receive data in 2-dimensional form. This leads to the fact that our program can't always capture facial performance with high sensitivity. Secondly, we have a relatively simple avatar model. The accuracy of facial expressions depends on the number of nodes in the avatar model. Our model does a good job, but we can always build a more complex model with more nodes, which can convey emotions more subtly. Thirdly, the third stage of our project contains a neural network, which is responsible for transferring emotions. In its training, the value of the loss function was reduced to a minimum, but it's only for the models that we built. Maybe further research will reveal the way to optimize and improve this neural network, and then the error may also decrease. And finally, we artificially limit the flexibility of the face that can lead to rougher facial expressions. This limitation is done in order to avoid artifacts, like unnatural distortions and deformations of the avatar. Actually, this error is not related to anatomical peculiarities and differences, because our program works not with the person's face itself, but with its changes relative to the neutral expression. So, whatever the face is, we memorize its neutral version and then look at how the position of the key points change. The possibilities of facial expressions are roughly the same for all human faces. Regarding the plans, at this point the plan is to create new avatars with different looks and added textures. Adjusting the 3D model for each person individually is not planned yet.
Wow, is it related to the anatomy of the human skull and how it differs from the 3D model of the head?
Well, first we built a neural network model which takes the key 68 points of the avatar's face as the input and gives us 136 parameters for the 3D model as the output. This model consists of 3 blocks. The first one works with the points of left eyebrow and left eye, the second one with right eyebrow and right eye, and the third, the last one, with points of nose and mouth. These blocks work independently and in parallel, and such division is made for the model to be able to work independently with movements in these mentioned areas. For example, if a person moves the left eyebrow, it won't affect the right eyebrow. The architecture of the 3 blocks is practically the same. This neural network includes 5 fully connected layers, between which there are non-linear layers with Likert loop and the layers of batch normalization. Next, the dataset was generated to train the model. This neural network works with the key points of the avatar, not the person, which means that we need lots of 3D avatars with different emotions. To do this, we randomly generated 60,000 sets of points, each of which specifies an avatar with particular emotion, and constructed all those avatars in 3-dimensional space based on these sets of points. Then we extracted the key 68 points from each avatar and in total got a dataset of sets of points. After that, these dots are fed to the input of the neural network in batches. As the output, we get some parameters. Using these parameters, we build the avatars in 3-dimensional space and find the differences between the input sets of points and the key points of the obtained avatars. This difference is the error or bias, and in fact represents the value of the loss function. Then, a gradient descent is performed using Adam optimization, which provides training of the network and reduces the magnitude of this error. This model is trained in this way on all batches of the data, gradually lowering the error. And that's the whole process of the training. In addition, a small noise is added to the key points in order to make this model more robust to human emotions. Also, loss function penalizes large avatar parameters because they set obviously unnatural facial expressions. So, all in all, this model is trained on 60,000 different facial expressions.
Are there emotions or facial expressions that the model is not able to repeat on its own?
It seems difficult to isolate any specific emotions, but they're definitely there. In particular, this can be extreme facial positions that characterize very vivid emotions. The avatar can't always replicate them.
Actually, I want to clarify about parameters. What are these 146 parameters by which facial expressions are constructed on a 3D model?
The 136 parameters include 100 parameters responsible for various emotions and 36 parameters that set facial flexibility. The value ranges of these parameters were obtained experimentally, and when the parameters are within their ranges, the avatar takes on natural facial expressions and deforms in a natural way.
You said that the facial expression on a 3D model is constructed by taking into account 146 parameters previously studied by the model. Is this number of parameters exhaustive and sufficient to accurately reproduce facial expressions on a 3D model?
The number of parameters, especially considering the low complexity of the avatar model, is exhaustive, since every combination of 136 numbers sets its unique emotion. There are an awful lot of such emotions that can be generated. However, if you want, you can change the ranges of the parameters themselves in order to adjust the accuracy of facial expressions.
Sounds good. Well, where can such technology be implemented? Maybe where at the moment can it be used?
Actually, this technology is not technically demanding, as it's capable of receiving video from a regular camera and running on a processor. In view of this, the possibilities of implementing this technology in various devices are wide. At this point, this program can be run on a laptop or desktop computer.
Well, next question. Is the technology unique? Are there any competitors like technologies or programs?
Well, this technology of course is not unique, because the field of animation has been developing for quite some time. And there are analogs that perform a similar task. One of them is a face rig application released in 2014, which allows animating an avatar using the voice and emotion. Despite the program's long history of development, the research in this area is still going on to this day. For example, in 2020, University of California researchers published Fast and Deep Facial Deformations, which explores the technology of avatar animation. And it's worth noting that we came to some of the thoughts and ideas in our work through the article. We didn't have a goal to make a unique product. We just wanted to develop an application that could perform the task of animation without requiring special technical equipment from the user. And this program can run on a laptop with ordinary processor and standard webcam.
Nikita, thank you so much for being here. That was a good one. Really appreciate our conversation.
Thank you, Andrea. That was cool.
If you want to see more of our interviews, just subscribe to our channel, and if you want to receive more helpful information, just check it out on brutalab.com.